yeah, that's right. Thank you. Douglas, sorry. Linda reminded me. Douglas, can you start recording? Okay, thank you. All right. Okay, so first order of business today before we do anything. We are going to be using two screens, one to illustrate locking, because locking by its nature is an inter-process thing. And we actually have, I set up two screens here, and for you to switch over, you have to press Control A, Control A. So you hold Control and press A twice. So I'm gonna switch over, and I'm gonna see you over there. All right, Linda, Tony's there, Manohar, Tom is there. I think I'm missing Rob. Rob decided to abandon us. I see Douglas and Rob are still missing. So if I want you guys to press Control A, Control A. Hold the Control button and press A twice. Even on a Mac, you should still use the Control button. Not the Command button, the Control button. I see Douglas joined us. Rob, still don't see you. Okay. Um, your Control A might be mapped to somewhere else, and we might remember Rob. Rob, remember when you have to disconnect from my session, you press Control A, then the letter D. Let's try. Uh, let's try pressing Control A, then the letter A. Actually, that doesn't do anything. So never mind. Let's try something else. Control A 1. No, Control A 0. Okay, Rob, why don't you try typing Control A, then the number 1. See if that will do the trick. Yeah, I'm not sure if that's gonna solve it, but you're free to try. That's okay. So that you could give it a try. So I'm going. This is for everybody else. Oh, here you are. I see you now, Rob. That's good. You made it. You made it. All right. So for everybody else, Control A again to go to the first screen. For Rob, Control A, the number 0. Yeah, mine is not working too. Okay, I'm switched over. Okay, good. Tony and we have Rob still there, still missing. All right, and there's Rob. All right, we are in business. Okay, so hopefully we will not be doing this a lot. We're just going to be doing it to illustrate the effect of locking. So, all right, as I said, I was going to talk about locking, but let's talk about the importance of locking and MUMPS. The MUMPS language The first M in MUMPS stands for Massachusetts. The second M stands for multiple. The fact is, MUMPS was sort of one of the first languages that allowed multiple users to use the system at the same time. And back in those days, they called it something fancy, time sharing. Nowadays, time sharing, is a destination place where you get ripped off. So, um, to enable the multiple to enable multiple processes to use to actually coordinate with each other, MUMPS invented something called the lock command. And lock command has been pretty much in the MUMPS language since its very beginning, but its form has changed slightly. So the first thing to know about the lock command, it's called lock, upper or lowercase doesn't matter, and its abbreviation is just an L. And the way it works is as follows. It functions as a signaling mechanism. It does not lock the database against other updates. All right, this is really important. When I say, for example, so the code above seems to say lock the patient file. It does not lock the patient file. That's important. This really does not lock the patient file. What it does is instead is it locks and it creates a semaphore. I'm not going to try to explain what that exactly means, but let's just say it's sort of a signaling node called up_DPT. And so anybody who is also trying to lock up_DPT will fail to lock it. So essentially, for locks to work in MUMPS, all processes contending for the lock must try to lock the same semaphore/node. It's not semaphone, semaphore. All right. So I'll give you an example. All right. Let's start with the very, very, very simplest example. So how does VISTA make sure that you're not adding two patients with the same name at the same time? It's a good question. Let's take a look. Let's see, what's it called? DG-Reg. All right. This is the patient registration routine, and I'm trying to find where the lock is. The lock is somewhere hidden here, but I'll find it. There is set oh, okay. This is the unlock. Here it is. Let's see, highlight, please. No, here. Okay, do you guys see the highlighted line? Now, here's the funny thing. Here's the funny thing. There is no such global called temp DFN registration in progress. This does not exist. That's important. That's really important, okay? Here's that's the lock acquisition, and then here's the unlock. It's below it. So quitting this, so let's sort of underscore this. I can lock plus up caret blah blah blah. Mumps does not care. I really just lock that. So, and my lock name does not have to be a global variable. It could also be a local variable. So I could say lock plus blah blah. So there's a GTM command to show locks is Z show L, and in cache it's up caret lock tab. You do you have to do up caret lock tab to see the locks. But essentially, what happened right now? I just locked the up caret, the one with the global or one with the local variable. The important thing I want to emphasize in all of this, that the locks do not have to correspond to a real global. They could be any name as long as it's a legal mumps name, including globals with subscripts. So let me show you the other command that I wanted to talk about. Lock without any arguments. Guess what? They're gone. So lock without any arguments will unlock everything. Okay, so that's what we've covered so far is essentially a basic overview of the lock command. So let's talk about its syntax in detail. So the lock command had an old syntax. It's not allowed to be used anymore. I'm going to show you the old syntax just so that you would know that it exists, and if you ever in your life manage to see it. I actually saw it yesterday in some code I was looking at, but apparently it was dead code because nobody bothered to refactor it. So the old way to do a lock was like this. So let's say I wanted to lock record 1 in the patient global. All right, let's look at our locks. Good. Let me say that I want to lock the SH node under the patient global. Let me do that. Let's see. Oh, look at that. Did you notice something? It replaced it, exactly. So the old way of locking could only do so I'm just saying locks on a line. I'll explain to you why in a moment. But it could only do it at a time. if you try locking again, you lose your old locks. So that's important. That's the old syntax, and we don't tend to use it. So how did those people who actually did the old syntax do multiple locks on multiple nodes? Or if they, so what they did was, they did something like this. To lock multiple nodes, you just put multiple locks in a comma between parentheses. And here you are. And if I lock something else, again, I'm going to lose it. Okay, good. So that's the old syntax, and I'm showing you how it works. So let's talk about the new syntax. Then we call the new syntax incremental locks. So I'm going to unlock everything to make sure that it's empty. So everything is unlocked now. Now I'm going to do lock plus. Notice the plus. That's the big difference. All right, then I'm going to try locking. Then I'm going to try locking a third thing. Okay, so far so good. And just for the hell of it, I'm going to lock the SH1 again. Now notice now that GTM is now going to say that SH is locked twice. So now I could remove locks one at a time. So lock minus, that's the opposite of the plus, dpt1 comma EV. That's gone. Lock minus dpt of 1. That's gone. Lock minus dpt of 1 comma sh. That is not quite gone because we have two of them. So we have to unlock it again. And here it is. Okay, very good. That pretty much covers the syntax. One important thing that you have to know about locks, besides, actually, there's one more thing in the syntax, is that locks can take timeouts because you can't necessarily guarantee that you'll be able to lock something. So before I show you the timeout, let me show you what happens when another process tries to lock a node. So let's say I'm going to lock let me type this out, see what happens when all right, so let's try to lock char dpt sub 1. Okay, good. So it locks here. So I'm going to go to the other screen. So Control A, Control A. All right, computer, anytime now. Is it just me or did anybody else move? No, nobody moved. Okay. All right, I moved. Okay. How about you, Linda? Oh. Oh, you moved and then moved back. Okay, here we go. Rob, you were there and you're gone. I'll wait for you all, guys. So All right, I think that's everybody. Manohar, I don't see you there. All right, so you have to type Control A, Control A. So hold Control and press A twice. Okay, you got it. All right. So let's try locking the same node. Oh, no, that's not right. Didn't I lock? I locked one. Okay, sorry. Linda tells me I locked one. I did not lock zero. Okay. All right. Guess what? Guys? What do you think happened there? Linda thinks it froze. Manohar actually has the right answer. It did not freeze. It's actually waiting. GTM is waiting until the other lock is released. So I'm going back to Control A, Control A. Oof, this thing is driving me nuts. Oh, here we go. So what I'm gonna type now is lock minus up caret dpt of 1 and hit enter. So far so good. Let's switch back to lock 2. What you will see is that GTM is not waiting anymore. It actually finished. All right. So what's the lesson for the day, so to speak? Lesson for the day is locking something is pretty dangerous. It could cause the system to freeze or appear frozen. So as a rule, and this rule is in the VISTA standards and conventions, whenever you try to lock something, you should do it with a timeout. So now typically in the VISTA world, you use two kinds of values for timeouts. Most of the time you try to do a lock with 0 seconds. Actually, let me switch back. Okay, so most of the time, I'll wait for you guys. I switched to the other screen. That's what I meant. Okay. Oops, somebody switched back. All right, good. So most of the time, the way you want to lock something in VISTA is you want to do lock of plus up caret, whatever global you want, timeout of 0. And this way you would know whether after you do that, you're gonna test the value of $test, which we talked about. That's the same variable used by if and else to see if the lock succeeded. So I would say if 2 spaces, right, lock succeeded, else, right, lock failed. So guess which one? So did the lock succeed or fail here? It failed. So this prevents us from having a problem where when we try to lock something, we would freeze up the system. You have to put a timeout on your locks. That's important. So let's take a look. Let's take a look again at Let me just take a quick look. Begin reg. Okay. All right. So this is the routine that we just looked at. Who wants to tell me what the lock is? What the lock is in what the lock timeout is in this example? All right, that's correct, Tony. It's 1 second. Oh, Tom, no, it's not 1 minute. It's 1 second. 1 minute is a century in computer time. So you notice that there is sort of another lock in here. So I want to take a look at it. So let's take a look at it. So zprint. Oh, here you go. And here, that's actually a very easy function to read. Wow, one of the simplest functions in my life. So here it says, if you can lock it he tries to lock the patient, and this time it's 2 seconds for a timeout. And if he succeeds, he's gonna put it in, quit with the value of $test. Do you guys need a refresher on $test or not? Okay, sure. So in MUMPS we have, so let's just talk about $test briefly. So MUMPS is not just an imperative computer programming language. I call it mother of imperative. And $test is there to tell whether MUMPS should execute the if or the else. And so several commands set $test. The most common one that we use is if. So I'm gonna write $test, should be 0. So if 1, that essentially, it should tell you write hello, write $test. Now MUMPS knows that $test is 1. Therefore, when I write the else command, I need to write, let's write by, and it doesn't work because $test is not 0. So let's give it another try. If 0, this means if it's not true, write hello, write $test, else write by. So this is one big use for $test, and sometimes we don't check it. We don't check it that directly when we're doing if and else. Now the other thing about $test is that any function that takes a timeout in MUMPS, like a read, an open, or a lock, we just covered locks, if they succeed, they all set $test. So if I try to lock Sam, oh, sorry, I have to lock the variable Sam. It's not really a variable. We said it's an imaginary variable for MUMPS. And now if we write $test, it should be true. Oh, no, hold on. Sam is wrong. Sorry, guys. Okay. Lock minus Sam. All right, I did it wrong. I said any command that takes a timeout, didn't I? Here you go. Here you go. So this is important. If you don't put a timeout, MUMPS will not set dollar test. And so, oh, Linda's shaking her head. What? You're okay? All right.
Strange.
It's strange. Okay, fine. So it's at so this is important for you so that you know you always have to use timeouts whenever you do reads in VISTA or you do locks or you do opens. Therefore, you should always be checking dollar test after it. So you always find a lot of code that reads like this. If not dollar test, write this failed and then quit. You see that a lot in VISTA. Again, you actually don't technically have to write that because if dollar test isn't true, you could just write an else. This failed. Quit. Oh, where's the right? Here you go. Because remember, okay, Linda has knitted eyebrows, which means it's really confusing. So remember that if sets dollar test to true, okay, and if you set an if whatever is true, don't run the else. That's how I remember it. Okay, good. Now open read lock with timeouts, set dollar test to true if they succeed, false otherwise. Which means we can use else to detect if dollar test is false. So the way it would go is like this. If it's gonna be lock plus up caret dpt of 1 else, right, cannot lock this, try later, quit. And that quits the entire routine and you're done and the user has to try again later. I forgot the timeout, didn't I? Oh my god. Sorry guys. Force of habit. Here we go. Okay. I think I talked enough about locks and they might be pretty confusing for you guys. I'm pretty sure. Linda's brows are so knotted that it must be really confusing. So, the big question for everybody, I suppose, is why the hell would I ever need to use locks? And to be honest, in most of my MUMPS programming, I never have to use locks. So the big question is, when do I actually have to use locks? So actually, it's the answer to when do you have to use locks is not that often. I'll show you how it works. So let's in MUMPS in general, the only reasons you need to lock something. So 1, 2 users cannot be doing the same action at the same time. An example of this, registering the same patient, you cannot do that. Another example, writing orders for the same patient. CPRS does a lock in order to make sure that people don't write people don't write orders for the same patient. Two, you are incrementing a counter in a global. You need to make sure that the counter is incremented by 1 just for your process. This actually happens a lot. What could happen if you don't do that is that two processes might increment the counter at the same time, and you end up with a counter that goes up by 2 instead of 1. And that could screw up your code. 3, in certain cases, updating data via fileman. Now, in general, fileman takes care of locking for you. So you remember, fileman actually has to do a lot of low-level operations in MUMPS. You know, fileman gets a record number, sets the header node for a record number. Each of these is an atomic operation, and it requires it to be locked. And it's very important that fileman not let two different processes acquire the same record number. Otherwise, they're going to overwrite each other's data. So fileman in general takes care of locking. There, there. I'm gonna have to check with Rick on exactly which old style APIs take care of locking, but I know about the new style APIs, which most of you are gonna use in your programming. So, file up_die by the you need to pass the L flag to it to lock. Update up_die by default locks. You don't need anything special. So, in general, then, over your programming career in MUMPS, if you ever get to write locking codes, it will be the exception rather than the rule. You're not gonna have to. You're gonna find a lot of code that you read that uses locks, but you won't find a lot of code that actually. You won't have to write a lot of code that actually uses locks. Okay. Let's actually run a little example. All right, good. I selected this patient and into this environment. Let me go to the second screen. So I'm going to press Control A, Control A. I'm going to try. Really, guys? It's letting me select it? Okay, I'm surprised. Maybe I have to go a little bit further. Okay, I'll switch back. Here you go. Oops. Well, I don't know why it disappeared, but where is it? Okay, here we go. Patient is being edited. No, that's not exactly the nicest, I have to say. So I don't exactly. I thought it's gonna give me a bigger warning. Okay. Here's that message. Patient is being edited. Try again later. So the way that this happened is that in the code that I just showed you in the patient file, it tries to lock because we are two different users, but we are running the same exact code. Therefore, the same lock node is being invoked, and the same lock node cannot be locked twice by different processes, and therefore we cannot both edit the same patient at the same time. So I'm going to show you another example, but I just want to pause here for questions. I want to see if anybody has any questions about lock. Can you lock it twice in the same process? Actually, Linda, the answer is yes, and we've actually just done that. I'll show you how. So here we go. Lock Sam. Oh, sorry. Wrong format. Here you go. Oh, no. L. Oh, see, I have Sam locked 3 times. So I have to unlock Sam again. I should still have 1. And unlock Sam again. Here you go. It's gone. Can you set more than one lock on the same line? That's a good question. Sure. Do you mean like this? Yep, here you go. All right, so that's the answer to that question. Anybody else have any questions? I'm gonna show you more examples of locks in a moment. All righty. I don't see anybody. All right. So oh, I want to show. Speaking of FileMan, let's do this. All right. So I'm going to show you examples of locks. Oh, whoops. All right, good. So I just tried to edit drug 1001. Let's switch to the other session. Aha, see that? And actually, if I catch FileMan in time, I can probably detect where is the locking happening. Okay, you see the lock is happening at lock +3 upcode DILF. So let's take a look at that code. All right, so he's locking something called ref, and he's adding a plus sign to it. Remember, he's using the indirection trick to convert a string into a variable. We talked about that. So let's see what ref is. And here is ref, PS drug of 1001. So this is important. So you'll notice here that FileMan is actually doing the locking for you. You don't have to do anything special. All right. And now we continue our wait, and it's going to tell us somebody else is editing this. All right, back to our original screen. So Control A, Control A. Let me show you the other example I wanted to show you today for locking is this one. And this is from a package I'm actually working on right now. So I saw this code and I thought it would be perfect for class. Now remember I was telling you about the global incrementer, and this is an example of an incrementing a variable in a global. And here you are. This is the code we'll be looking at. And so it's doing a lock, and this lock is taking 60 seconds. So this lock is taking forever. Actually, MUMPS will wait 60 seconds to try to lock this. And I guess, the programmer was not in a hurry for this to happen. Then he gets that global. He adds 1 to it. That's an increment. Then he sets the actual same global using the naked global notation. When we have up caret with parentheses, it means use the last global, but add this last subscript, which in this case happens to be the same. And then this is equal to the sequence number. There's another operation, and here's the unlock. Okay, so over here, same thing, except that this is the opposite. And no, the 60 means Manohar. It means that MUMPS will try to acquire the lock for 60 seconds. So basically what the programmer is betting on is that these 2 lines down here between the locks will take much less than 60 seconds. No, that's not correct. It will not release a lock. It means it will try to acquire the lock for 60 seconds. And if it can't acquire it, the code should fail. In this case, this is not well-written code here because the programmer has no else to plan for what happens if it fails. He just sets the global anyway. So that would be considered a bug in this code. But the programmer is betting almost correctly, I bet, on saying that these 2 lines down here where between the lock and the unlock will not take 60 seconds. And it's a safe bet, actually. So let me see if I could find one more lock. And here's a lock, but let's see this done unlock. Where's the lock? Okay. Here's an interesting one. So I'm going to highlight this so you could see it. So this is a lock, and it's for 3 seconds. And notice the else. Do you see that else? So he says, try to get locked for the 3 seconds, and then if this doesn't succeed, else do. And then he writes, someone else is adding a patch at the moment. Please try again later. And then he quits, and you're done. Otherwise, he does all this work. And again, you could see a lot of the work actually involves getting variables and incrementing them. Now, if he actually used FileMan, he would not need to do that. But he does the locking as well for FileMan, but it's not strictly necessary. And this is another case where, again, he is betting that nobody's gonna lock this for 60 seconds, and so he's counting on the fact that the next 2 lines between the locks are actually gonna get done in much less than 60 seconds. Therefore, the next process waiting in line while this is locked will have a chance to move ahead because this one it will not take 60 seconds to execute these lines. Let's see if there are any more locks. Okay. This one is interesting in the fact that it has no locks. But remember what I told you about FileMan's update up_die? It will do the locking for you. You do not have to do any locking. Okay. I have a feeling that a lot of you guys are confused. Open for questions again. Any questions? Okay, uh, the lock with the time or without the time? Manohar. Without. Okay. So if if the pro so if the programmer as an example did not put 60 seconds here, so he just deleted it. Let me go ahead and delete it, for example. What that means is that MUMPS is going to wait here until if somebody else has it locked. So let's pretend that process 1 locks this and then moves here, and process 1 is still on this line. Now, let's say process 2 starts and tries to execute the lock. What's going to happen is that process 2 is going to stop and wait. And what process 2 is going to wait for is process 1 to reach this unlock line. And once process 1 unlocks this, therefore process 2 could acquire the lock and move forward. Does that make sense? Okay, good. Now, just as a contrast, if you have the time, what that means is, let's make this just 1 second, okay, rather than 60 seconds. If you have a timeout, it means that if process 1 starts, acquires the lock, and is at the second line and just waits at the second line, what's going to happen is process 2, when it hits the first line, it's going to wait to try to acquire the lock only for 1 second. If it does not succeed in acquiring the lock in 1 second, the programmer should have written something like else quit, which basically says, I'm done here. I'm not going to try again. So, but if the process succeeds, $test is going to be set to 1 because it's successful, and the rest of the code will get executed. And at this last line, the unlock is happening. All right. And any more questions? Okay, good. All right. So, like I said, in your MUMPS programming career, if you know it gets any length, what's important is for you to understand. Oh, here he has a very good point. I'll tell you what happens when you forget to unlock. What's important to understand for you in your MUMPS programming career is that you need to be able to read how locks work, because when you actually get to use them, that doesn't happen very often, actually. All righty, a good question, Manohar. I'm so glad you asked that question because I almost forgot to mention it. So what happens if you forget to unlock? Well, remember that patient when we're registering a patient and we lock that patient when we're registering it? What if we forgot to unlock it? Well, what happens is nobody else will be able to edit that patient. Not forever. So Linda asks, forever? No, not forever. Locks live as long as the mumps process live. So if the mumps process gets killed or the user logs out, the locks get released. That's very important, actually. So I'll write it down. So locks are tied to process. If the process dies or user exits most of the time, the locks are gone. If you forget to unlock and the process lives on, other users will be prevented from moving forward. Okay, let's see. The other thing I want to tell you about is the fact that I think our last lock topic is that lock minus global or lock minus local always succeeds. So it will unlock it if it's there. Otherwise, it won't do anything. So it's not going to throw an error. So let's look at our locks. So I have Linda and Sam here. So I could say lock minus Linda, lock minus Sam. Nothing here, but can I do this? Yes, I can. Mumps will not complain. Right now it's just a no op. Mumps doesn't do anything anymore with it. All right. Last chance to ask any questions about locks. You can ask an email. That's okay. Okay, please repeat the last thing. Okay, so what I was saying, the last thing is that the lock minus always succeeds whether the lock exists or not. It will not throw an error. So remember, like if I do write x, this throws an error. It tells you there's no such variable as x. But if I do lock minus Linda, it always succeeds. It's not an error condition. All right. Okay, good. So, that takes us to our next exam topic, which I want to actually. This is something we covered, but I want to cover it again because it's really important. And to be honest, guys, it's more important than locks because you're not going to use locks that often. So what I want to cover is I want to cover extrinsic functions because when I covered it, we sort of rushed it and it wasn't too clear. So I'm going to cover it again. So we're going to cover extrinsic functions. And what are extrinsic functions? The way you use them is the $2 sign. So an intrinsic function means that it's part of MUMPS extrinsic function is user defined. So here's an example of an intrinsic function. So this is an intrinsic function. It's $extract, and $extract is part of MUMPS. An example of an extrinsic function is write $$ upcaret xlf str. That's the routine it's in. And it's going to capitalize your letters. You can write date upcaret xlf str, and maybe it's today. Okay. Oh, DT. Haha. Here you go. That gives you today's date in fileman format. So let's talk about how to construct an extrinsic function of our own. So I'm going to make a routine for myself. Oh. I don't know whether we're gonna get to doing a Fibonacci sequence or not today, but let's just get started. So let's make an entry point called add x and y. So, and remember that to make an extrinsic function, the thing is you have to use the quit with an argument. So x plus y quit with z. All right. This differs from a do block. I know we're going to cover both of these. So write hello to my generator. Now read number 1 colon. We're going to call this A, and I better new A here, new A and B. Read number 2 B. And then we're going to say write sum is underscore add a comma b. And we quit, and let's delete this line. 50. And we run this routine by, we're gonna do intro, then quit. All right, so this should give us at least a good feeling for how these things work. So remember I showed you how to debug stuff. We put a Z break. I'm gonna put a Z break on K-band fib, and I'm gonna get that special thing that I paste into my screen when I'm debugging. And then I'm gonna run the routine. All right, let's look at our current line. All right, so it's gonna do intro. So let's look at our stack. Z show S. Okay, fantastic. So Z step into, and here you go. You get to hello to my generator. So I must be in intro. So you see that my stack level now is, this is 1, this is 2. I should be at 2, right? Dollar stack, I'm at 2. So Z step into. Here you go. Enter 2 numbers. Gonna put 3. I'm gonna put 4. So the sum should be 7. Now, I just want to show you the stack again. So we're still at K-band fib plus 2 and intro plus 7. So Z step into. Now, so it printed the string this and then went to this entry point. Now we're passing stuff by value here. We don't have a dot in front of the A or the B, which means pass by reference. So it's passed by value. So that means that A and B we're gonna get their values are gonna be copied and they're gonna be put into new variables called X and Y. So write X, it's 3, write Y. And let's take a look at our stack. So we went from first level, second level, third level. So write dollar stack, and it should be 3. So what's important here is that what we understand the fact that when I call an extrinsic, it's the same as calling a do, except that I get a value back, which I either could write to the screen or could set into a variable. Now, since I don't have something on the syllabus, I'm going to show it to you guys now very quickly, and we're going to mark it off as we discussed it briefly. But if you want to know more about it, you're going to have to consult some reference. So dollar stack actually has a special way. Dollar stack as a variable could also be an intrinsic function, and you pass it dollar stack place and M code, and it tells you what the code is and what your place was. So if you want to go below, you could start with the level below, and you could see place M code, and you could do -2. And dollar stack of -3 does not exist because that's going to give us dollar stack of 0. Now, besides the subscripts place and M code, there's a subscript called E code. And we're going to discuss this during the next class. We're not going to discuss it today. But the E code will give you whether the stack is actually has an error at that moment. So that's my little diversion into dollar stack. We're not going to discuss it again, except maybe briefly next week. So Z step into. So set Z equal X plus Y, write Z. We're still at the third level. Z step into. All right. So we got the value written out, which was the value of add. Then we're going to hit the quit. And we're going to go into this. And that quit is popping a level of the stack. We should be at, we just popped one from the add. So we should have two left. And we just popped one at intro plus 8. So we should have one left. Ah, wrong. Here you go. Right, dollar stack. And that's it, we're done. Right dollar stack should be 0 because we're at the very bottom. Okay, I'm opening the routine again. If I could find it. So, does anybody have any questions about this simple routine? The whole point of this is to make sure you guys understand the difference between an intrinsic and an extrinsic function, and the difference between calling a block with a do and calling a block with $2 signs. Okay, good. If you guys understand it, I am indeed very thrilled. So let's think of how we're going to implement a Fibonacci sequence. Thank you, Linda. So I'm going to try to do a Fibonacci sequence. So I'm going to make a new entry point. So I need a quick refresher on a Fibonacci sequence. Remind me, Linda. 1, 1 plus 2, 1 and then 2, and
1, 2, 3, 5.
2 plus 3, right? And then 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. Right? Okay, good. All right, I think I got it. 1, 2, 3, 5, 8, 30. All right, thank you. Thank you so much. That should help me. So I try to remember how it worked. So, all right. So what we need to do is we actually need to have a loop which adds the result of every addition to ourselves. So so our first number is let's make it equal either the number or 1, whichever is defined. I'm planning great things with this. So I'm gonna say, so write the number plus the previous number before it, right? So the previous number before it, so we have to store the old number. and the first case is going to be 0. All right, I'm trying to ease my way into this. So write number plus old num, comma, space. And then what do I need to do next? I'm thinking. Old number equal number. Oh, thank you so much, Manohar. Set old number equal to number, and we just call it again, and it's going to be the number. And what is going to be the old number? What's going to be the new number is going to be the old number, and number is going to be, yes, you're right. Thank you. That's a great idea. Thank you so much. So let's set num equal num plus old num. And down here we just write num. And then we set old num to equal num. And we actually could just move this line up above here. Ah, whoops. No, that should be. Oh, we want the old number to be. Hold on a moment. Here's the old number is 0 and 1. We add 1 plus 0 gives us 1. Let's make them a different number. Let's make num2 and old number 1. We add, so that gets us 3. Then the old num. You set first old num, then number. Thank you. Okay. Like this. Okay, thank you. And then we're gonna let's add parameters num comma old num. So we said we're gonna, now you said Manohar that we're going to pass what? Let's try that. I'm not sure. Quit if num is greater than 20. Quit. That's never gonna get invoked. Okay, we have it wrong, obviously. So let's figure out what's wrong with it.
Oh,
Uh-huh.
you set the old num to the num equal to num before you do the.
Before I do the addition, so that's not gonna work. So let's delete that. How about, so here's the new number. Here's the new number, okay. So num is the new number. Actually, let me not, maybe not update it. Maybe I shouldn't update it then. let's just say right num plus old num. Yep. And then I call the function again with num plus old num and old num. Actually, this. How about this? Would this work? It might. Okay, guys, help me here. It's not just Linda and Manohar. Yes, we got the Fibonacci, didn't we? We did. Okay, we want to tell it to quit when numbers above 2000. So we get some. All right. Let's see. I'm comparing it against Manohar's number. 1, 2, 3, 5, 8, 13. Yoo! All right. So we wrote a little Fibonacci sequence. So I wanna show you some important features in our programming that might not be immediately obvious. So there is one thing special about this function, and it's the fact that it calls itself. So it keeps calling itself, calls itself again, calls itself for every time. So what's that doing in effect is that it's actually adding levels to the stack. And therefore, uh, if we had if our number was really huge, we might just run out of stack levels in GTM. That's a possibility. So that's one thing it's doing. And when it hits the quit, what happens is because it's on a high level of the stack, it keeps it hits this quit, then the previous function goes back here, and then it hits this quit down here. Remember, the first function is gonna quit over here. Then the previous function was stopped here, then it's gonna hit this quit. Then the previous function stopped here, and then it's gonna hit this quit. Linda's confused.
No, Linda's looking for her Fibonacci program.
Oh, Linda's doing for her Fibonacci program. Okay, sounds good. All right, so this is so this is what we call in computer science recursive functions. In our case, you know, we might we're just what's the word? I'm trying to think. We're writing it out. We could change it so that it actually returns this as a function. Oh, that's okay. I'll forget about it. It's not that important. So the other feature I wanted to show you guys was the use of $get. So $get says here that I get me the value of number or 1, whichever one is defined. If number is not defined, it defaults to 1. And here we go, old number, and again, it's another default. So this is a good way to actually set your parameter values to defaults if you don't want to actually pass them. So you notice that I do not pass any parameters here, and it works. I can pass 2 and 1, and it's going to start with 3. All right. That's what I wanted to show you. And let me think. Anything else? Nope, I don't think so. Oh, before we break, I need to mention that next week there is the possibility I will not be teaching this class because I'll be at the Vista community meeting teaching a class on how to configure Vista. And so I don't have any students signed up over there yet. And so if I do get maybe a couple of students, I'm going. Otherwise, it's really not financially worth it to me. So um, I don't know yet whether I'm going to have people there, but if I do, I'll let you know via email. And so we will not have class next week. Okay, and the other thing I want to mention is, I hope you are working on your projects, and uh, if you uh, if you need time, we sit together. Can you please email me, and I'll set some office hours so that we could go over things together. Actually, I think it would be a good idea for me to set office hours anyway, but just let me know if you guys have a specific time you prefer. All right, that's it for today's class, and I will hope to see you next week or the week after.